The lesson is part of the topics in the senior high school subject, Understanding Culture, Society, and Politics. It tackles the biological foundation of culture and revisits the development of the human species from the earliest times and the implications to the present. The story shall begin in the moment the universe came into being. Time, space, energy, and matter came into existence around 13.5 billion years ago, in what is known today as the Big Bang. That first story was the story of physics. 300,000 years after, the first atoms emerged, and there unfolded the story that was chemistry. Soon, in our corner of the universe, the interaction of matter and energy made its way to form the solar system, and ultimately a planet we call home, Gaia, Earth, that was 4.5 billion years ago. This planet will carry in its bosom atoms and molecules which combined into more intricate structures imbued with life, called organisms. That was around 3.8 billion years ago, which marked the beginning of the story called biology. In this long story of eons and billions of years, it was only around 70,000 years ago when that creature of immense intellect, the Homo sapiens, came into worldly being, creating more elaborate structures different from nature. We call that culture. Then we began to actively modify the world and our destiny, thus making way for history. We will usher through at least three important revolutions that will shape our history. One, the cognitive revolution. It was the first, and it culminated around 70,000 years ago. Second, the agricultural revolution, about 12,000 years ago. And the scientific revolution, around 500 years ago, which immensely changed human history. The first two shall be the subject of the presentation. There were humans long before the Homo sapiens. Hominids roamed the planet as early as 2.5 million years ago. And they were not special. They did love, played, had simple tools, formed relationships, and competed for status and power. But so did the chimpanzees, so did the baboons and the elephants. Our ancestors were animals of no significance, without any trace that someday their descendants will walk the moon, split the atoms, or clone themselves. The question we are to ponder on in this lesson: how we, Homo sapiens, emerged to be the modern humans we are today. Before going any further, let us first do a little review of biology or particularly taxonomy. As we know, organisms are classified into species. They are of the same species if they tend to mate with each other and produce fertile offspring. For example, horses and donkeys may actually mate as they share many physical traits, for they descended from a recent common ancestor. They may possibly produce offsprings. We call them mules. But these mules are sterile and unable to reproduce a hybrid and new species of its own. Horses and donkeys, therefore, are not of the same species. They, however, can be grouped together under the same genus. Lions and jaguars, for example, are distinct species, but they are of the same genus, which is Panthera. Humans are grouped within the genus Homo. Genera, plural for genus, are then bunched into families. Jackals, foxes, dingoes, and wolves, they belong to the same family, the family of dogs, which is Canidae, for they all descended from a common evolutionary ancestor. Homo sapiens, like them, has its own family. We had relatives, yet it is a mystery why we are the only member of the hominid family around. Why are we all alone? Why are all of our relatives are missing and gone? These questions haunt humanity like skeletons in the closet, yet rarely we come into terms with and had difficulty in answering. We prefer to view ourselves as one of a kind, special, and set apart from all animals, without siblings nor cousins, without parents and ancestors. The closest living relatives we have are those we are affiliated in the order called primates, chimpanzees, orangutans, and gorillas. Descendants we are of those archaic apes which parted into distinct genetic rifts around 6 million years ago. One way to understand ourselves better is to recognize ourselves as one of the many members of the hominid family. We shall now venture into meeting our non-sapiens siblings. The earliest hominids found in the fossil record were the Australopithecines. These apes of the genus Australopithecus roamed around East Africa about 2.5 million years ago. Australopithecus literally means southern ape. Two million years ago, some of these apes migrated around and out of Africa into the north of the continent, into Europe, and into Asia. Varied geographies dictated the development of distinct traits to suit different environments. These hominids evolved in different directions, resulting to the development of different human species. Among them were the humans first discovered in the Neander Valley in Germany, the Homo neanderthalensis. They populated Europe and Western Asia. The Neanderthals were of bigger stock compared to Homo sapiens. They were bulkier and more muscular. They had bigger brains and they were built to last through freezing climate of the Ice Age in the temperate regions. They used tools and fire and hunted. They clothed themselves and they took care of the sick and buried their dead. Neanderthal bones with physical handicaps were discovered, evidence that they were taken care of by their relatives. While on the eastern parts of Asia, there walked the most durable human species ever, the Homo erectus, the upright man, who lived through 2 million years before going into extinction. In comparison to our species, the Homo sapiens are not yet in its first 100,000 mark. Definitely the Homo erectus. They were the most durable of the human family. Early humans walked the earth and found its way to the peripheries of Asia in the island of Java, in today is Indonesia, then connected by land to the continent. Archaeologists found the remains of the tropically suited man from the Solo Valley, the Homo soloensis. As the sea level rose, when the ice of the glacial age melted, some of them get trapped in the nearby island of Flores. Dwarfed by geography, as resources were poorer in the isolated island, these humans were to be known as Homo floresiensis, and to many it was popularly nicknamed the Habits. They were short at only 3.5 feet and they only weighed 55 pounds. They hunted with stone tools the elephants of the island, which were like them, small and dwarfed by time and geography. Recently in 2010, a fossilized finger bone was unearthed at Denisova Cave in Siberia. It was not like anything already discovered and later named as a distinct species, the Homo denisova or the Denisovan man. As many of our siblings migrated and evolved in many parts of Africa, those who remained in the continent evolved as everyone else. A species was found in Lake Rudolph, thus named Homo rudolfensis. We also had the working man, as its name is literally translated, the Homo ergaster. And our very own, the species we egocentrically call Homo sapiens, the wise man. They were varied and different in sizes, in tools, in habitats and diets, but they all belonged to the same family, Hominidae, and genus Homo. They were all human beings. They did not evolve from each other. One human species did not beget another one. This is contrary to the popular illustration depicting a straight line of evolutionary descent. They were siblings, and at times in the past, around 2 million to 10,000 years ago, they lived and walked at the same time. The question again is, how come we are alone today and have almost forgotten our multi-species past? What happened to our siblings along the way who were responsible for their extinction? Are we? Humans are big thinkers. It is our extraordinarily large brains that is the hallmark feature of our species. In comparison, mammals weighing near to an average sized person around 130 pounds or 58 kilos have an average brain size of 12 cubic inches. Compare that to 36 cubic inches of brain early humans had 2.5 million years ago, and to present humans 73 to 85 cubic inches average brain size. It is not that more is better, it is more of the size of the brain relative to body weight. But ironically, giant brains are not usual among animals. Jumbo brain is a jumbo drain to body's energy. It will be heavy, hard to carry, and harder to fuel. The human brain accounts only 2% of the body weight, yet it consumes around 20 to 25% of an individual's energy at rest. Among apes, it will be only 8% of their energy at rest. No such thing as a free lunch. Early humans had to pay the price for possessing larger brains. 1. They need to constantly and more frequently search for food. 2. Larger portion of energy allocated to the brain means lesser for the rest of the body. Human muscles atrophied. Muscles became smaller as biceps are exchanged for neurons. Jumbo brains, nevertheless, paid off well. Man cannot brawl or wrestle with a chimp, but he can sure think of ways to defend himself. Maybe create weapons or produce fire. And yes, sure, a chimp can't win an argument with a Homo sapiens. Another hallmark feature the human species. Another hallmark feature of the human species is the ability to stand upright on two legs. Bipedalism was crucial to man's survival. She cannot outrun a cheetah, but an upright posture gave her a higher vantage point to scan and prepare in advance for coming predators. Moreover, the arms, our arms, were freed and made available for other purposes, such as holding tools and throwing stones. More things were to be done by the hands. The importance of the hands put evolutionary pressure on our physiology. This explains why nerves and finely tuned muscles are concentrated in our hands. This made man the toolmaker. Evidences of tool production were dug and dated as early as 2.5 million years ago. Again, no free lunch. Walking upright came with a price. Until today, evolution hasn't perfected our adaptation to an erect posture. Humans are plagued by backaches, stiff necks, and spine-related diseases. Women paid the extra price, as being upright required narrower hips for women. Narrower hips meant narrower birth canals. As the skulls of human babies to be delivered got bigger, as our brain size increased, and while the birth canals got constricted and became smaller, death in childbirth became a common cause of death among women. Natural selection will later dictate that babies should be born earlier and prematurely. Smaller they were at birth meant more chances that they will survive. Thus, the human infant is prematurely delivered. At birth, we are weak, helpless, and vulnerable. Compare him to a newborn horse, which can already walk and run immediately after birth. The unintended consequence of helplessness at birth was the greater chance of getting socialized and educated. The underdeveloped creature may then be shaped according to the ways of people around him. Additionally, a woman who had to rear children cannot search for food or do other survival chores, and therefore required the assistance of family members and neighbors. Thus, premature births fostered stronger social ties. Among humans, it really takes a village to raise a child. We might be the most powerful animal on earth today, but in the scale of time, we were for a great long period the preyed and not the predator, the hunted and not the hunter. This fearful existence down the food chain was our condition even during the time already we already had the jumbo brains and the arsenal of stone tools at our disposal. Looking at the fossil record, for a very long time, we will find man gathering plants for subsistence, indulging on little insects and small animals for protein, and devouring on the leftovers of larger and more powerful predators. Scientists suggest that our stone tools were originally meant to crack leftover bones, not to hunt bigger animals. Our original niche in the ecosystem was in waiting for the big predators to finish their meal and then salvage the bones to be cracked open for the delicious marrow inside. For millions of years, we were in the middle of the food chain. Our rise to the top is only a recent phenomenon. It was only 400,000 years ago that humans hunted for games bigger than them on a regular basis. And it was only in the last 100,000 years that man leapt on top of the food chain from hunted to becoming the hunters. This very recent jump explains certain aspects of our present psyche and social problems. In nature, a predator's rise in the pyramid takes time. making way for its prey to adjust as the predator adapts. On the other hand, man's ascent to the top happened drastically within short period of transition time, making no space for everyone else to adjust, thus causing enormous imbalance in the ecosystem. More importantly, man suffered the consequences. His newly acquired might overwhelmed his psyche. Though powerful, we are insecure as a species. We carried over today our fears and anxieties we had before as the fearful hunted and as the nervous prey. Our insecurities led us to catastrophic consequences, from committing everyday crimes to deadly wars and ecological destruction of massive scale. Man the insecure, who was overwhelmed of a newfound might, with weapons on his hand and nuclear missiles controlled by his fingertips, had to confront himself, and many times he failed. But how did humans jump to the top? One significant tool she had was fire. Fire was occasionally used as early as 800,000 years ago. It was subdued and domesticated for daily use by Homo erectus, Neanderthals, and archaic Homo sapiens around 300,000 years ago. Fire was a source of light, warmth, and a weapon to ward away predators. Fire was also used to torch savannas, thereafter collecting the burnt animals and charcoaled nuts and root crops. Above all, fire will find a revolutionary purpose for man, the best thing it did, and that was to cook. It won't be possible to eat today's staple food, which are rice or wheat or corn, without the discovery of fire for use in cooking. Cooking changed food's chemistry as well as its biology. Cooking made food safer as parasites and germs are killed in the process. One more thing fire and cooking did was the lesser effort we have to dedicate into chewing and digesting. Fire became our external stomachs. Animals may take time to tear their food and chew them raw, but man may consume his meal in less than an hour, thanks to cooking. Softer food and less chewing made way for smaller teeth and jaws and shorter intestines. Shorter intestines were directly linked to the advent of cooking. In physiology, the brain and the intestines are the massive energy monsters in our body. Smaller intestinal tracts meant lesser energy consumption, thus making more energy available for our jumbo brain to use. Thanks to fire and cooking, the brain got much needed fuel. Now, we confront the question of what happened to our brothers and sisters. Scientists agree that when Homo sapiens came into being, there were still other human species around and in existence. What then happened? One theory tells of a story of attraction, sex, and mingling. It is called the interbreeding theory, which narrates that the Homo sapiens that migrated from Africa mixed with the other human species, and we today are products of those ancient affairs. Following the theory, the Eurasians may be said to be a mix of Neanderthal and sapiens, while those from Eastern Asia are products of interbreeding between Erectus and the sapiens. Another theory is in opposition to interbreeding theory, the replacement theory. It tells of a die-off due to competition for resources, or the possibility of an incriminating narrative of genocide. The theory proposes that the human species were not anatomically compatible. They had different mating habits and body odors, thus exhibited little sexual interest for each other. They were genetically distinct that any offspring they may have will be infertile. It concludes that the Homo sapiens replace all the other human populations. Thus, we are all pure sapiens. We might have driven them into extinction by competition and violence. Human behavior, as we'll know, is marked by intolerance to things and people different from ours. Case in point, a difference in skin color had actually sparked violence and catastrophic actions toward each other many times in our history up to the present. It was not impossible that we killed our brothers and did launch an ethnic cleansing campaign against them as they were different from us. The replacement theory may be incriminating, but was more acceptable and was less politically charged as the interbreeding theory. Interbreeding, as critics fear, may actually open a Pandora's box of racism as we begin to see ourselves greatly different at the level of our genes and ancestry. But the theory gained points over replacement theory as the findings of the Human Genome Project was published in 2010. It was found out that modern humans of Europe and West Asia actually comprise 1 to 4% of Neanderthal DNA. Adding to the evidence was the findings that 6% of those in Melanesia and the Aborigines of Australia are actually Denisovan DNA. As things got more complicated, a conclusive agreement on the debate is still not around. The answers to the question of what happened to our siblings are yet to be settled. What if the Neanderthals or the Erectus are still around today, side by side with modern humans? What kind of cultures, society, and political structures would have in a world with several human species? What species would be Adam and Eve? Would Christ may have been here to save the sapiens alone or together with the Neanderthals and the Denisovans? Who will be referred to as men when the French Revolution declared all men are created equal? Would Karl Marx call for all workers of all species to unite? Yet, the reality of being alone is our condition today, and in the past 10,000 years, our lack of siblings make it easier for us to set apart ourselves from the other species. Any attempt to liken and affiliate man to another species, as Darwin did when he proposed our affinity with apes and monkeys, will be met with doubts, objections, and even outrage. In the part 2 of this presentation, we shall tackle another hallmark feature of the human species, that intangible tool we have, our unique language. Maraming salamat po. Delphi Commons is a complementary effort of the MHPNHS community to the DepEd Commons, which aims to make educational resources available to the Filipino learners online, aligned with the learning competencies set in the K-12 curriculum.